log, no more complex than anything you've ever seen yet. We're just a log base 10. We don't write the 10. That's the thing about it. But it is the most useful, the most easiest, because everything's in a 10, exponentials of 10. So if I asked you what the log of a 100 is, what would that? What is the exponent of 10 that makes 100? 2, right? Because log. So you're thinking the base is 10, which is not written there, but this is 10 squared, so the answer is 2.
Oh, I see what you were asking me. That's not what my answer was.
Now it is. What about 10,000?
It's going to be like 10.
What exponent of 10 makes 10,000?
No.
10 cubed is 1,000. 10 to the fourth is, how many zeros?
4.
Whoa! This is why we went to base 10 number systems. Right? The Babylonians used base 60. How enjoyable would that be?
Not at all.
Okay. Computers are very simple. They use base 2. Right? Base 10 is the easiest to use.
Why would you do that?
If you're in sciences, chemistry, pH is an application of base 10 logarithms. Okay, so maybe that looks familiar. So this is the concentration
What is that bottom under the one?
of hydrogen ions in a solution. Give me a sec, this is a nice statement. It's beautiful. In moles per liter. Okay, that's an H plus. Why is it a plus?
Don't ask me. Electricity, positively?
Yeah, hydrogen ion is a positively charged ion. Okay. That's why we put a plus. It just denotes the positive charge of hydrogen. There's an extra electron. Right. Yeah.
So if the common log 10 to the second is just as log to the second. It can't be just log 10 to the second. Not log to the second, because you said we don't write the 10.
Right. You don't write that 10.
Right.
Yeah, so we don't write this here. That's all you would write. Because there's a base 10, but we don't write it down. Okay. So it would be, if we wrote it, it would look like that, but we don't. So good question to clear up. I kind of blow past things like that. Okay. This concentration is usually a very small number. Okay, so if you had something like a concentration of 10 to the negative 7, what is the pH of that solution? Using your exponent properties, what can I do with that? What? I can't hear you, so I don't know either.
We don't know. Today feels like Friday.
What does the negative on the bottom do to this term?
It'll flip.
Brings it up. Same thing, right? Okay. Negative exponent here moves it up or down. That's all you got to remember. What is that answer? The log base 10, 10 to the 7th. So the exponent is 7. The pH of that solution is 7.
Right.
But keep in mind, this is like scientific notation.
10.
So it's 0.1. That's the concentration of hydrogen ions in moles per liter. So they're 0.000001 moles per liter in that of hydrogen in that solution. That's how we come up with pH. So Richter scale for earthquakes is a very similar development. Okay. But I'll spare that. It's just they're just powers of 10. Okay. Powers of 10. So anything of this nature would be something you could do without a calculator. Okay. What about calculator okay? Base. Is that what base is that log?
10.
Base 10, because it's not written. 7 is not a pretty exponent of 10, right? You can't get it by just doing 10 squared or something. So this is where you type in your calculator log 7. Okay, the log key on your calculator is base 10. So log 7. Boom. 0.845. Again, that means 10 to the 0.845 is 7. It's not going to be perfect because I truncated that decimal.
6.9.
So you have, if you look at your calculator, see how if you round it off, you're going to get
A different number, yes.
how accurate you need to be depends on the application. For construction, of course you have to use logs, but that would be accurate enough, right? But our missile defense system that the Navy has developed is shooting down missiles going 2,000 miles an hour with another 2,000 mile an hour plus missile hitting it. You're going to have some decimal places, like lots, hundreds probably, but there you go. Did I ever tell you the story about that in the Iraq War?
No.
Gosh, I'm so far behind the time. On my birthday in 1990, we attacked Saddam Hussein in Iraq. I was 9 years old, January 17th. It's the only reason I remember the date. Saddam Hussein started firing, so Iraq is very close to Israel. So Saddam Hussein starts firing Scud missiles into Israel as retaliation for us attacking him. Okay, because he had occupied Kuwait, a peaceful country to the south, so we kicked his butt out of there, right? And we just kept going to Baghdad. We had what's called Patriot missiles. They're a mobile missile battery that when a Scud's launched, it should intercept it, blow it up, right? Well, we were missing. They were all missing. Miss. What the heck's going on? Okay, well, they figured out, like, computer memory has so many digits you can use, like 16-bit memory, you can go to 16 decimal places, etc., right? So they figured out that they didn't have enough memory, and the decimals were truncating in the mathematical equations these computers had to calculate, and they were missing. So they put more memory in them, increase the size of the number in decimal places, started making them happen, started protecting it. So, a little application of decimal significant digits, really. And that was more of a computer programming thing, but it came down to math. So, there you go. It's just a little interesting things. Who knows why I remember it? Okay, so that's evaluating. Our calculators are pretty functional nowadays, so what I'm going to show you now can be helpful in using the log properties and practicing those, but your calculator can still manage these. Okay, so if you've got a problem like simplify log 5, your calculator can just slam that number out, right? Didn't used to be the case, but now it is. So, but if you see something like that, you can manipulate it with the properties of logs. And I would suggest you do that for practice, for that memory quiz. Okay. For instance, what can you do with an exponent here based on the properties of logs? Yeah, you can move it out front. Oh, hold on. Not yet. We have to do these things in order. Okay, does that 5 have a cubic on it? So we can't move it yet. It just doesn't have one. So how can we split these two up? Yep. Okay, there we go. Now we can move the 3 down, right? So that would be simplifying it by hand. If you wanted the decimal, punch it in the calculator. Okay, let's put that in and see what we get. .6. That's hard. Hey, look at that, he's right. Again, here's another one, simplify. Let's try it on your own, actually. Yeah. Properties are right here. Is there an exponent here? So we'll deal with the division first. There's your simplified version, and then if you get the decimal. Yep. You okay with that?
Yeah.
What?
He said he understands it. He wants.
So you, more than most people in this room, like to see the application of math and say, boom, there. That's good. All right, that's it for the day. We will finish 11:05 on Wednesday, hopefully.
All right.
And so NWA tomorrow. I will give you a primer for Tuesday tomorrow as well, using parent function stuff. And let's practice in there. Tuesday we should finish this. No, Wednesday we should finish this. So, making ground. If you need some help with logs, come get it, come here.
It's 11.5.
Thursday. Try if I'm here Tuesday, we will do the next section. So try to have this part of it done as much as you can by Tuesday. But I doubt I'm going to be there, just to be honest. But that'll be official.